Hey, chums of Examsnet. Welcome to the question series of Examsnet. Today we'll be solving AP EAPCET 8 July 2022 Shift 2 paper. There will be about 80 questions from the mathematics for this paper. So let's start with the very first question. But before that, students, if you want to practice all these and many more entrance exam question papers, then do visit our website www.examsnet.com. Here you will find a variety of question papers and PDFs, and a number of problems will be solved over there. So you can also download our app. You have the link in the description box. So let's start with the very first question of the paper. Best of luck. Hope you're well prepared. So now let's do some practice. Here we go with the question number 1. It says if the function is, if there is a function f from real numbers to real numbers, this is defined by fx is equal to x into mod of x. Then, we are having only one problem, and that is this mod of x over here. Let's write on the function. We have fx is equal to x into mod of x. This gives you that this is x into x if x is greater than 0, and this is actually equal to x into minus x if x is less than 0. Okay, so that makes fx is equal to x square when x is greater than 0, and this is equal to minus x square when x is less than 0. Also, you have one more condition, that this function is from real numbers to the real numbers. Now let's plot the graph for this one. I have this. So this is your x-axis and y-axis. Let's plot the graph. It's got to be something like this. Right? So this is a continuous curve. This is the graph. This is fx is equal to x square, and this is fx is equal to minus x square. Right? Over here. And fine. So according to the graph, the domain of the function, is equal to the range of the function, and that is equal to the real numbers, right? Therefore, range is equal to codomain, and that is equal to your R. This implies that your fx is an onto function. First thing. Now, if a line is drawn parallel to the x-axis, if I'm drawing a line, this, which is parallel to the x-axis, it will intersect at only one point of fx, for sure. That means if I draw a line parallel to the x-axis, it will intersect at only one point of fx. This implies that this is one-to-one function, one-one function. Also, so we have both onto as well as one-one function. Let's check which is that one. We have option C as our answer. Hope you're clear with this. Let's move to the next question. Question number 2. The domain of the real valued function fx is equal to, this is, you have to find out the domain of this real valued function. Your function is fx is equal to root of 2 minus mod of x upon 3 minus mod of x whole under the root. So here fx to be defined, this whole thing, because this is under the root, for fx to be defined, This whole term which is under the root, that is 2 minus mod of x upon 3 minus mod of x, it should be greater than equal to 0. Now, first thing, case 1, if x is greater than 0, why? Because I'm having a mod of x over here. If x is greater than 0, then 2 minus x upon 3 minus x. That means this should, if this is greater than 0, then this 2 minus x upon 3 minus x, this is surely going to be greater than 0, which implies x minus 2 upon x minus 3, this is also greater than 0. Let's try to plot this thing on the graph. See, if this is the graph, here I have the minus infinity and here I have the infinity. So the graph is something like this, right? It is on the negative side over here. This is 2 and this is 3, right? Here I'm having the plus 1. The graph is positive. Above this x-axis and downward the x-axis, it's got to be negative, right? Therefore, thus x will belong to minus infinity, comma 2 inclusive, union 3, comma infinity. Next, we have the second case in which x is less than 2. Then what will happen? See, if x is less than 0, sorry. When x is less than 0, we will take the mod of x as like minus x, which will make our expression, that is 2 minus mod of x upon 3 minus mod of x. It will be 2 plus x upon 3 plus x. This has got to be greater than 0. Now let's plot the graph for this one also. I am having infinity over here, minus infinity over here, and it will be like this, minus 3, minus 2. I have a minus value over here and the positive values over here, right? So thus in this case, x will belong to minus infinity, minus 3, union, minus 2 and infinity. So this is your second, name it as number 2 equation, and not equation actually, conclusion, and this one be to be number 1. Now the third case. See, you can't have the denominator 0. That means 3 minus mod of x can't be equal to 0, which gives you mod of x can't be equal to 3. That means simply x cannot be equal to 3 or minus 3. Both are not possible. So now let's name it as equation 3. From equation 1, 2, and 3. If I conclude all the conclusions that we have seen, so you will have x will belong to minus infinity to minus 3, union, minus 2 to 2, union, 3, comma, infinity, right? So this one becomes our answer. We are done with the question. Let's check what we have in the answer. Yes, we have option D as the answer to our question. Hope you are clear. Next is question number 3. Question number 3, if A and B are n into n squared matrices, then such that 2a plus b whole square plus a minus 3b whole square is equal to 5a square minus 2ab plus 10b square, then ab into ab is. So you are given, let's write down 2a plus b square plus a minus 3b square is equal to 5a square minus 2ab plus 10b square. So let's open up the brackets. You will have 4a square plus b square plus 2ab plus a square plus 9b square minus 6ab is equal to, is equal to 5a square plus minus 2ab plus 10b square. So now let's take everything on the LHS so that you can have minus a square and minus 9b. This will be equal to, sorry, this is 4a square plus a square, they will cancel out, and b square, 9b square, this will cancel with this one. Okay, and 2ab minus this will be minus 4ab is equal to minus 2ab, right? Okay, this is where I'm saying minus 2ab. This can be written as minus 4ab is equal to question number 3. If A and B are n by n square matrices such that this equation is true, then AB multiplied by AB is given by what? Let's write down the equation. That's 2AB. These are the matrices. Square plus A minus 3B square is equal to 5A square minus 2AB plus 10B square. Let's apply the formulas and I'll open up these brackets. You will have 4A square plus 2B square plus 2AB plus 2BA plus A square plus 9. This will be, this plus 9B square minus 3AB minus 3BA. I'll bring the whole RHS on the LHS. So it will become minus 5A square plus 2AB minus 10B square is equal to 0. So let's solve. You will have, these will cut, and B square plus 9B square minus 10B square, they will cut out. And you will be left with, see, this is equal to minus AB minus BA is equal to 0, which gives you AB is equal to BA. Not minus this. This is plus. Yeah. Okay. So, yeah, AB minus BA is equal to 0. This gives you AB is equal to BA. Then AB can be written as this, this, which is equal to A multiplied by A into B multiplied by B. That is equal to A square B square. So option D is the correct answer for the problem. Hope you are clear. Let's move to the next question, number 4. So if this is the adjoint matrix of this matrix, then A plus B plus C plus D is this. So you are said that this is the adjoint matrix of this. Basically, what do you have to do? We will find out the adjoint matrix of this given matrix. Okay, to find out the adjoint matrix, first of all, let's find out the cofactors of the matrix. So cofactors for the matrix, let this be A, 1, 2, 3, 2, 3, 1, 3, 1, 2. So the cofactors of this matrix, cofactors will be given by, I have to solve this. So very first one, this will be C11, C12, C13, 21, 22, 23, 31, 32, and 33. Let's find out the C11. So it will be given by, first of all, minus 1 raised to power 1 plus 1 whole multiplied by 3 multiplied by 2 minus 1 multiplied by 1. 3 multiplied 2 will give me 6 minus 1. This will give me 5. So I'll keep on writing the matrix cofactors actually over here. So the very first one will be 5. Second one, C1, 2. So minus 1 raised to power 1 plus 2 whole multiplied by, I'm leaving the first row and second column. So this will be 2 2s are 4, minus 3 1s are 3. That will give me a minus 1. Similarly, C1, 3, minus 1 raised to power 1 plus 3. 2 1s are 2, 3 3s are 9. This will give me minus 7. C1, 4, minus 1 raised to power, not 1 4, sorry, 2 1. So 2 plus 1 whole multiplied by, this will give me 4 minus 3. So this is minus 1. C2, 2 will give me minus 1 raised to power 2 plus 2, 2 minus 9, that is equal to minus 7. So let's write it down. Here you have minus 1. Here we have minus 7. Minus 1 minus 7. C2, 3 minus 1 raised to power 2 plus 3. C3, 1, C3, 2, C3, 3 is equal to minus 1 raised to power 3 plus 1, minus 1 raised to power 3 plus 2, minus 1 raised to power 3 plus 3. So 2, 3. This will be my 1 minus 6. This is 2 minus 9. 1 minus 6. 3 minus 4. This will give me minus 1. This will give me 5. This will give me minus 7. This will give me 5. So let's write down. Let's complete the cofactors. So here you have 5, minus 7, 1, 5, and minus 1. These are the cofactors. So let this be something equal to B. This matrix represents cofactors of matrix A, right? How do we find out the adjoint of a matrix? Adjoint of matrix A is transpose of the matrix B. So B was, let's see, the B was, okay, it's split up. Transpose of the matrix B will be written by 5 minus 1 minus 7, minus 1 minus 7 minus 5, minus 7, 5, and minus 1. In the question, this is given equal to 5A minus 7, B minus 7, C minus 7, D minus 1. So after comparing, you will get A is equal to B is equal to minus 1. Also C is equal to D is equal to 5. So what do you have to find out? You have to find out A plus B plus C plus D, which is equal to minus 1, plus 5, which is equal to 8. So we got our answer as 8, and this is the correct answer, option A. Hope you're clear with this. Next is question number 5. The rank of the matrix this is. So you have this matrix A as this. I will not rewrite it. To answer the question, you have to find out the rank. For that, let's apply some transformations on this matrix. So we are going to apply the elementary transformations. Let's apply. First, R3 can be written as R3 plus 2R1, and the second transformation will be R2 can be written as R2 plus 4R1. Right? After applying this transformation, the matrix A will become 1, minus 1, 0, minus 2, 0, 0, 0, 0, 0, minus 1, 2 and 0. This will be matrix after applying these transformations. Now, let's interchange second and third row. R2 and R3, they will be interchanged. Let's go for that. So, A matrix can be written as 1, minus 1, 0, minus 2, 0, minus 1, 2, 0, 0, 0, 0, and 0. Now, matrix A is in the row form. Matrix A is in row echelon form. Number of non-zero rows is 2. Therefore, the rank of the matrix is 2. Let's check. I have option D as my answer. Right? Clear with this? Next is question number 6. If A is this matrix, is not invertible matrix, and the sum of all the values of A is. So this is not an invertible matrix. The A matrix is given by this because A is non-invertible matrix. A is non-invertible matrix. Therefore, the determinant of A can be written as 0. That means 1 into A plus 1 minus 1 minus 1 minus A minus 1 plus A plus 1 into 1 minus A plus 1 square is equal to 0. Let's open it up. You will have A plus 1. No, this is 1 will get cancelled. Yeah, this will cancel and even this will cancel. So you will have A plus A plus a plus 1 minus a plus 1 whole cube. Okay. Yeah, this is equal to 0. This gives you 3a plus 1 minus a cube minus 1 minus 3a square minus 3a is equal to 0. This gives you minus a cube minus 3a square is equal to 0, right? Because they will cancel out with this. So let's take a square common. You will have a minus 3 is equal to 0 plus 3. Minus will cancel, so you will have just a square. A square cannot be equal to 0. Okay, wait. A plus 3 is equal to 0. A square, of course, can be equal to 0. So you can have the values of a as 0 or minus 3. So these are the two possible values of a. Now it's saying you sum of all possible values of a. There were two possible values of a, that is 0 and 3. So the sum is equal to 3. Right? 0 and minus 3, sorry. So the sum is equal to minus 3. Option A is the correct answer for the question. Clear? Next is question number 7. If x minus iota y raised to power 1 by 3 is equal to 2 minus iota root 3, then this point lies on the line this, then value of k is what? All right, let's write down x minus iota y raised to power 1 by 3 is equal to 2 minus iota under root 3. This is given to us. So let's do the cubing both the sides. You will have x minus iota y is equal to 2 minus iota root 3 whole cube. Let's open the cube. You will have a cube. Then you have b cube minus b cube, which will be equal to 3 root 3 iota cube. Minus 3a square b, which will give me, minus 3ab. So this will give me 6 root 3 iota into 2 minus iota root 3. So this is equal to iota square is equal to minus 1. This will give me 3, 8 plus 3 root 3 iota minus 12 root 3 iota. Iota square will be there and then that is minus. So it will be 18 minus 18, right? This is equal to x minus iota y. So this gives me minus 10 minus 9 root 3 iota. This is equal to x plus iota y. So if I'm assuming this to be equal to some z, I'm naming this complex number as z. So z lies on the plane. Z lies on the line x upon 2, it's given in the question, y upon root 3 is equal to k. So let's fill in the values. From here, we get the x as minus 10 and y as minus 9 root 3. So let's fill in over here. It will give you minus 10 upon 2 plus minus 9 root 3 upon root 3 is equal to k. They will cancel out and you will have minus 5 and minus 5 and minus 9. These are the two values. Wait. Here is a small correction. This was minus. So y is actually 9 root 3 and x is minus 10. So this is plus. Correct? This will give me minus 5 plus 9 is equal to k. That means k is equal to 4. So this is our answer to the question. Option D is the correct answer to the question. Hope you're clear with this. Let's move to the next question, number 8. Question number 8. If modulus of z plus 2 upon z is equal to 2, then the maximum value of modulus of z is. Oh, here we have the z as the complex number. And you have to find out the maximum value of this modulus of this complex number. Right? First thing, there is a bit change in the options. This option is not, this is not Z over here. This is actually 3 over here. All right. So let's start with the solution. Because we are having the modulus of Z, this can be written as Z plus 2 upon Z minus 2 upon Z. Now this thing for sure is less than equal to modulus of Z plus 2 plus modulus of 2 upon Z, right? This gives you modulus of Z is less than equal to 2 plus modulus of 2 upon Z. So let's do the cross multiplication on both the sides. I'll be multiplying with this 2. Actually, I don't need to write the mod on here. This can be written as mod of Z is less than equal to 2 plus 2 upon mod of Z. This will become mod of Z square minus 2 mod of Z is less than minus 2 is less than equal to 0. Hope this is clear till here. Now let's complete the square. This will give you modulus of Z square minus 2 modulus of Z plus 1 minus 3 is less than equal to 0. So here I will have modulus of Z minus 1 whole square is less than equal to 3. So modulus of Z minus 1 will be less than equal to root 3. Modulus of Z will be less than equal to root 3 plus 1. This is, see, the maximum value of the Z will be at root of 3 plus 1, right? If I see it on the graph, this can be shown as here you can say minus infinity, and this will represent minus infinity. So this point is over here, not the point over here. This is 1 minus root 3, and this one is 1 plus root 3. I'm having the plus over here, and the minus over here. So see, the Z will be maximum at Z maximum will be at 1 plus root 3. Okay, so this, this one thing, this Z was belonging to 0, 1 plus root 3. So Z is maximum as 1 at 1 plus root 3. Option A is the correct answer. Right? Clear? Next is question number 9. So a complex number Z among the following which does not satisfy this equation is, all right. So you are given the equation Z cube plus 27I is equal to 0. This can be written as Z cube minus 3I cube iota cube is equal to 0. Iota square is equal to minus 1. So I can write down 27 iota as minus 3 iota cube. Like this. Okay. So now for the solving, this is a cube minus b cube, which can be written as z minus 3 iota into z square plus 3 z iota minus 9 is equal to 0. If z minus 3 iota is 0, which this gives you z is equal to 3 iota. Second, if z square plus 3z iota minus 9 is equal to 0. Now applying the your quadratic formula, you will get the value of the z as minus 3 iota plus minus root of minus 9 plus 36 whole divided by 2. That is equal to minus 3 iota plus minus 3 root 3 upon 2. So the z can have two values, which is 3 root 3 minus 3 iota upon 2 or minus 3 root 3 minus 3 iota upon 2. These are the two values of z which are possible. So a complex number z which among the following which does not satisfy this equation is, see, over here I have option. See, all the options are not satisfying this equation except option A. So I think this question is which satisfy this equation. A complex number z among the following which satisfy this equation is option A. right? Next is question number 10. So you are given if modulus of z minus 3 iota plus z plus 5 iota modulus is equal to 4, then you have to find out the locus of z. Let's go with this. So you are given modulus of z minus 3 iota plus modulus of z plus 5 iota is equal to 4. It is of the form z minus z1 plus z minus z2 is equal to some k. So let's go with this. I'll name it as number 1. So now this equation 1, it actually represents ellipse if k is greater than z1 minus z2. Equation 1 represents ellipse if k is greater than z1 minus z2. Here z1 is minus 3 iota. No, it is 3 iota. Z2 is minus 5 iota. That means Z1 minus Z2, if I'm doing, that means I'm doing 3 iota plus 5 iota, which is equal to 8 iota. So this is greater than this 8 iota is actually equal to 8. And you know K is equal to 4. But we have the condition that K should be greater than Z1 minus Z2. Here we have K is less than Z1 minus Z2 mod. Therefore, no such point Z exists. So we have option A as our answer. Right here. Next is question number 11. The number of pair of consecutive positive even numbers such that sum of their squares is 290 is. So first thing, you are given number of pair of consecutive even, positive even numbers. So let x and x plus 2 be two consecutive positive even integers. Now, you are given that the sum of their squares is 290. That means x square plus x square plus 4x plus 4 is equal to 290. 2x square plus 4x minus 286 is equal to 0, or x square plus 2x minus 143 is equal to 0. So solving it by spreading the middle term, you will get the two values of x as x plus factors, actually x plus 13 and x minus 11 is equal to 0, from where you will get the two values of x as minus 13 and 11. Now you're given that they are positive even numbers. So I'll ignore this minus 13 and you have 11, right? But the problem is 11 is not even. You were given that they are positive as well as even. So minus 13, it's not positive, it's not even. And even the 11, it's not even. So I'm having 0. So the number of solutions to this problem is 0. Number of solution is equal to 0. Let's check the number of pair of consecutive even numbers, positive even numbers, such that the sum of the squares is 290 is 0. Option A. Right? Next is question number 12. The range of the function, this you have to find out. So, well, let's go with this easy question. You have this function, let it be y. Let's say this as y. Y is equal to x upon x square minus 5x plus 9, which gives you x square y minus 5xy plus 9y is equal to x. This will give me x squared y minus 5y plus 1 into x plus 9y is equal to 0. For x, belonging to the real numbers, the discriminant should be greater than or equal to 0. That means b square minus 4ac should be greater than or equal to 0. Right? So what is the b in this case? It's minus 5y plus 1 square minus 4 into a is y and c is 9y. This should be greater than or equal to 0, which will give you 25y square plus y plus 10y minus 36y square is greater than or equal to 0, minus 11y plus 10y greater than or equal to 0. I'm missing this one. Okay. So let's do the splitting the middle term. Okay, first let's multiply both the sides with minus sign. You will have 11y squared minus 10y minus 1 is less than or equal to 0. So splitting the middle term, you will get 11y squared minus 11y plus y minus 1 is less than or equal to 0. 11y will be taken common. You'll have y minus 1 plus 1, y minus 1 is less than or equal to 0. So 11y plus 1 into y minus 1 is less than or equal to 0. Now, the critical values for the y will be 1 and minus 1 upon 11. These are the two critical values. Let's try and plot the graph for them. Same. So here's the graph. Infinity, and here is minus infinity, and you have a negative plus, and over here you are having 1. This point may represent minus 1 upon 11. Therefore, y belongs to minus 1 by 11 to 1 interval. Let's check. Option B stands to be the correct answer for the problem. Hope you are clear with this. Next is question number 13. Y squared plus z squared is equal to ayz. Z squared plus x squared is equal to bxz, and x squared plus y squared is equal to cxy. Then the value of this expression is. All right. So first thing, you are given that y square plus z square is equal to ayz. Now, this can be written as y square upon z square upon yz. Dividing both sides by this will give you a, right? Similarly, if, okay, let's open up this further. You will get y upon z plus z upon y is equal to a, first thing. Similarly, you will get second one. I'll pick up this one. So let's solve this. So you will have z square plus x square upon zx is equal to b, which gives you z upon x plus x upon z is equal to b. Now let's pick up the third one, which says you x square plus y square is equal to cxy. So this will make it x square plus y square upon xy is equal to c, which makes the further equation as x upon y plus y upon x is equal to c. So I have these three equations with me. This is number 1, number 2, and number 3. So let's multiply 1 and 3 first. We will have y multiplying equation 1 and 3. So y upon z plus z upon y, x upon y plus y upon x is equal to AC. Now, this can be further written down as x upon z plus y square upon zx plus zx upon y square plus z upon x is equal to AC. Let's name it as number 4. Now, subtracting equation 2 from equation 4. you will get x upon z plus y square upon zx plus zx upon y square plus z upon x minus z upon x plus x upon z is equal to AC minus B. So when you will open it up, these two will get cancelled and this will also get cancelled. You will be left with y square upon zx plus zx upon y square is equal to AC minus B. And this is what you were asked in the question. Let's check. Y square upon zx plus zx upon y square. This is equal to AC minus B. So we have option C as our answer. Hope you are clear. Next is question number 14. Alpha and beta are the roots of this equation. Then the maximum value of alpha upon beta plus beta upon alpha when k is a negative number is. So given, you are given that the alpha and beta are the roots of the equation, that is 2x square plus 6x plus k is equal to 0. If alpha and beta are the two roots, so the sum of the roots is given by minus b upon a and the product of the roots is given by c upon a. B is the coefficient, A is the coefficient of x square, coefficient of x square, B is the coefficient of x, and C is the constant itself. So let's write down, these are the coefficients. What is the coefficient of x? It is 6, so minus 6 upon 2, which is equal to minus 3. Alpha into beta is equal to k into a, k divided by a, that is equal to k by 2. This is the sum of the roots and this is the product of the roots, right? You have to find out the value of this. Let's pick up this thing now. Alpha upon beta plus beta upon alpha. This gives me alpha square plus beta square whole divided by alpha beta. Now this alpha square plus beta square, this can be written as alpha plus beta square minus 2 alpha into beta upon alpha beta, right? Alpha plus beta, you know, see now I got everything in the terms that I know. Minus 3 square minus 2 into k by 2 whole divided by k by 2. So this is equal to 9 minus k. You'll take the 2 on the upper side. 2 will be here and k will be in the denominator. So you will have, this is equal to 18 minus 18 upon k minus 2, right? Because you are given that k is a negative number, because k is less than 0, so 18 upon k minus 2, of course, it's a negative number, right? For all k belonging to the negative numbers. Therefore, for the alpha upon beta plus beta upon alpha to have the maximum value, right? You may have this 18 upon k minus 2. This is equal to 18k minus 2. I'm writing this 18k minus 2 as like this. Now in order for this term to have the maximum value, you need to have, because this is a negative number, right? You need to have this equal to 0. Then only this whole expression will come out to be minus 2, which will be the maximum value. Otherwise, when you will add a negative number to it, the value will keep on decreasing. I hope you got this thing, right? So now, in order for this expression to have the maximum value, 18 upon k should be equal to 0. That means k should be less than 18, of course. Okay, so this is the value we were looking for. Option B is the correct answer to the question, because you were asked the maximum value of this, maximum possible value when k is a negative number, when k is when k is a negative number over here. So this can have a maximum value, right? So we got our correct answer, option D. Let's move to the next question, number 15. N minus 3 CR plus B N minus 3 CR minus 1 B N Yeah, this is Bn minus 3 Cr minus 2 and plus n minus 3 Cr minus 3 is equal to NCR. It holds for all n greater than equal to r greater than equal to 3. Then the value of b raised to power 1 is, this is not b raised to power 1 actually, this is b dash. Question number 15, if n minus 3 Cr plus b n minus 3 Cr minus 1 plus b1, or we can simply say b dash also, n minus 3 Cr minus 2 plus n minus 3 Cr minus 1 is equal to NCR holds true for all r between n to 3. Then b and b dash are equal to what? So you are given n minus 3 Cr plus b n minus 3 Cr minus 1 plus b dash n minus 3 Cr minus 2 plus n minus 3 Cr minus 3 is equal to NCR, right? So now I'll be, see, these are the two coefficients of b dash, b and b dash. I'll be adding them and subtracting them twice. So this equation will become n minus 3 Cr plus, this has to be done with very careful thing because a slight mistake can disturb the whole sum. Okay, so n minus 3 Cr plus 1, I'll put this one in brackets, plus n minus 3 Cr minus 1. Now n minus 3 Cr minus 2 I'm adding, and I told you I'll be adding this twice. So n minus 3 Cr minus 2 plus n minus 3 Cr minus 3 plus b minus 2 n minus 3 Cr minus 1 plus b dash minus 2 n minus 3 Cr minus 2 is equal to NCR. Right? Now, solving it further, you will get n minus 2. This can be written as n minus 2 Cr plus n minus 2 Cr minus 1. I'll put this one in the brackets again, plus n minus 2 Cr minus 2 plus n minus 3 Cr minus 1, n minus 3 Cr minus 2 plus, now b into, sorry, this was b minus 2 because I have added that already twice now. So now this time this will be b minus 3 n minus 3 Cr minus 2 because I have added this one also again over here, right? Plus b dash minus 3 n minus 3 Cr minus 2. This is equal to NCR. Hope you are clear till here. Now this can be written as n minus 1 Cr plus n minus 2 Cr minus 2 plus n minus 2 Cr minus 1 plus b minus 3 n minus 3 Cr minus 2 plus b dash minus 3 n minus 3 Cr minus 2. This is equal to NCR. Hope you are clear till here. So now this will be equal to NCR plus b minus 3 n minus 3 Cr minus 2 plus b dash minus 3 n minus 3 Cr minus 2 is equal to NCR. This will cancel on both the sides and you will have b minus 3 n minus 3 Cr minus 2 plus b dash minus 3 n minus 3 Cr minus 2 is equal to 0. Now this thing is only possible when b minus 3 or b dash minus 3 will be 0. That means b is 3 as well as b dash is 3. You had to find out this point, b dash, that is equal to 3, 3. So this is the answer to our question. Let's check. We have option C as the correct answer. Right? Next is question number 16. A student is to answer 10 out of 13 questions in an examination such that he must choose at least 4 from the first 5 questions, the number of choices available to him is. All right. So first thing, total number of questions are 13. Total number of questions are 13. Now, how many questions to be selected? Number of questions to be selected are 10. We have a restriction. At least 4 from the first 5 questions are to be selected. Restriction 4, at least 4 out of first 5 questions are to be selected. Then we have 2 cases over here. First case is if exactly 4 out of 5 questions are selected. First case, if exactly 4 out of 5 questions are selected. Number of ways in that can be done is number of ways for that will be given by 5C4, which is equal to 5. Right? Then how many questions are remaining? 6. Remaining 6 questions. I hope you got this thing, right? How you got this? This is 5 factorial upon 4 factorial into 1 factorial, which will give you 5. Now, remaining 6 questions are selected from last 8 questions. In how many ways? 8C6 ways, which will be 8 factorial upon 6 factorial into 2 factorial, that is equal to, into 5, that is equal to 140, right? Now, this is the first case. Second case says if exactly 5 out of 5 questions are selected. If exactly 5 out of 5 questions are selected, then number of ways that can be done is 5C5, which is equal to 5 factorial upon 5 factorial into 0 factorial, that is equal to 5 only. Sorry, that is equal to 1 only. Okay, right? Now, how many questions remaining? Remaining 10 minus 5, that is 5 questions are selected from 13 minus 5, that is equal to 8 questions in how many ways? That is equal to 8C5 into 1. Here was into 5, right? So 8C5 into 1, which will give you 8 factorial upon 5 factorial into 3 factorial into 1, that is equal to 56. So now the total number of ways is equal to 140 plus 56, that is equal to 196. So this is the answer to our question. We have option A as our answer. Hope you're clear with this. Next is question number 17. The number of ways of dividing 200 dissimilar things into 10 groups, each containing 20 elements, is given by which of these ones? Okay, let's understand the problem first of all. If we are given that there are mn objects, you have to divide them into mn groups of equal size. That is done by C. If division of mn objects into m groups having n elements of equal size, right? That means n elements. This is given by mn factorial upon n factorial raised to power m into m factorial. Similarly, now over here we are having the number of terms, that is m into n is equal to 200. Here we are having the groups as 10 and the number of elements in each group as 20. Therefore, number of ways will be given by 200 factorial upon n factorial raised to power m, that is 20 factorial raised to power 10 multiplied by 10 factorial. No need to solve it. We just needed this formula. So what we have, yeah, this is the correct answer, option C. Hope you're clear. Let's move to the next question, number 18. In how many different ways can three people, A, B, C, having 6, 7, 8, 1 rupee coins respectively donate rupees 10 collectively? So total number of ways, let's write it down. Total number of ways. This is equal to number of ways in which rupees 10 can be distributed among three people minus number of ways A can have more than 6 rupees. Number of ways A can have more than rupees 6 minus number of ways B can have more than 7 rupees minus number of ways C can have more than 8 rupees. Right? So the total possibilities are, this is given by n plus r minus 1 cn. This is equal to 10 plus 3 minus 1 c10, which is equal to 12 c10. That is equal to 12 factorial upon 10 factorial into 2 factorial, which is equal to 66. Now, A can have more than 6. This is what A can have more than 6. In A can have more than rupees 6 in 5C3 ways. That is equal to 5 factorial upon 3 upon 2, which is equal to 10. B can have, right, so B can have more than 7 rupees in 4C2 ways. That is equal to 6. Similarly, C can have rupees 8 in 3C1 ways. That is equal to 3. Right? Now, the total number of ways, according to the equation that we framed earlier, total number of ways will be given by 66 minus 10 minus 6 minus 3, which is equal to 47. So 47 is the answer to our problem. We have option A. Hope you are clear with this. Let's move to the next question. Question number 19. X square plus 1 upon x raised to power 4 plus 4 is equal to this whole expression. This implies 3a plus 2b plus 3c is equal to. So basically, you have to find out a, b, c values in the question. Let's pick up the LHS. We have x square plus 1 upon x raised to power 4 plus 4. So this can be written as AS, and I'll take up the this side also. Let's write it here only. This is AX plus B upon x square. This can be written as actually x minus 1 square plus CX plus D. This can be written as x plus 1 square, right? So this will become, I'll write the LHS as such, x square plus 1, x raised to power 4 plus 4 is equal to, let's do the cross multiplication. So question number 19, x square plus 1 upon x raised to power 4 plus 4 is equal to this whole expression. Then you have to find out 3a plus 2b plus 3c. So basically what you have to find out is a, b, c. That's it. Okay. Easy question, right? Let's write it down. It's x square plus 1 upon x raised to power 4 plus 4. This whole is equal to, I'm not going to write down the LHS. I'll be solving it. So let's do the, taking the LCM, you will have ax plus b is equal, multiplied by x square plus 2x plus 2 plus cx plus d multiplied by x square minus 2x plus 2 whole divided by, whole divided by, so now this can be seen as x square plus 2 minus 2x, and this can be seen as x square plus 2 plus 2x. This will behave as a, and this is b, so a minus b into a plus b is nothing but a square minus b square, right? Let's open it up. Let's write the LHS as such. You will have in the RHS. Now I'll be, instead of like opening the whole thing and then combining the like terms, we will just combine the like terms here as it is. Here I have x, here I have x, x square. So that means a plus c coefficient will be x3, x raised to power 3. Similarly, for x square, we will have the coefficient as 2a plus b minus 2c plus d x square plus 2a, 2b, 2c, 2d x plus 2b, 2d. Right? Whole will be divided by, if you will open this, you will have, give me a minute. So this will be x raised to power 4 plus 4x minus, wait, x raised to power 4 plus 4 plus 4x, 4x square minus 4x square. They will cancel out, and you will have, you'll be left with x raised to power 4 plus 4, which will cancel out with the LHS. So now you'll be left with only the numerator side. Now let's compare the coefficients. On comparing both the sides, you have a plus c is equal to 0, which gives you a is equal to minus c. Next thing, 2b plus 2d. This is the constant. That means this is equal to 1. Also, this thing, x square. That means this thing, 2a plus b minus 2c plus d is equal to 1. We got these equations. Now let's try and solve. So you will have over here, 2 will be taken common, a minus c plus b plus d is equal to 1, which gives you 4a plus 1 by 2 is equal to 1. That gives you 4a is equal to 1 minus 1 by 2, that is equal to 1 by 2, or a will be equal to 1 by 8. Right? You know one thing, a is equal to minus c, or minus a is equal to c, which will give you minus 1 by 8 is equal to c. We got the values for a and c. We only need the value of b now. Let's pick up this equation, the third one, this one. Okay, this one. The coefficient of x is not available on the LHS. So 2a plus 2b plus 2c minus 2d is equal to 0. 2a, 2b, 2c, 2d. This is equal to 0. And a we calculated 1 by 8. So this is equal to 1 by 4. B I have to calculate and leave B as such. But I don't know D. So let's do it other way. First of all, I'll write down 2a plus c plus 2b minus d is equal to 0. So, a and c, they are the negative of each other. So this thing will cancel out and you will have b is equal to d over here, right? So next thing that you had over here was 2b plus 2d is equal to 1. Let's pick up that. 2b plus 2d is equal to 1. So since they are equal, you can write down 2b plus 2b is equal to 1. That will give you b, 4b is equal to 1 or b is equal to 1 by 4. This is what the b is. Now, let's see what you had to find out. 3a plus 2b plus 3c. 3a plus 2b plus 3c. So a was equal to 1 by 8, b was equal to 1 by 4, and c was equal to minus 1 by 8, which, this is 3, right? So let's take the LCM. You will have 3 plus 4 minus 3, which gives you the answer as 1 by 2, right? Let's check with the options. Okay, I have the answer in the form of D. All right, okay. So this 1 by 2, actually, B is equal to D, right? So this can be written as, I have to modify this a bit. B is equal to D. Fine. So I'll redo this one because the options, they are given in the D form. So 3A plus 2B plus 2C. This is equal to 3A was equal to, this is equal to, here was 3, right? Give me a minute. Yeah, 3A plus 2B plus 3C. So 3A plus C plus 2B, A plus C, this is equal to 0. So that means we got our answer as 2B. But 2B is not available. We have answer in the form of D. Since B is equal to D, so this is also equal to 2D. Let's check with the options now. We have option C as our answer. Hope you're clear. Next is question number 20. It is a trigonometric problem. So let's solve 1 minus cot 23 degree is equal to x upon 1 minus cot 22 degree. Then x is equal to what? So let's do the cross multiplication. You have x is equal to 1 minus cot 23 degree multiplied by 1 minus cot 22 degree. So 1 minus cot 23 degree, this can be written as sine 23 minus cos 23 upon sine 23, right? See, cot you can write down as cos upon sine. So you can write the cot 23 as sine 23 minus cos 23 upon sine 23 as well. Similarly, 1 minus cot 22, this can be written as sine 22 minus cos 22 degree whole divided by sine 22 degree. Correct? So this will be, this whole will be, next is, yeah, we are done with this. Sine 23, sine 22. This is sine 23, sine 22 plus cos 23, cos 22. This whole will be in the plus one, and in the minus section you will be having sine 23 degree cos 22 plus cos 23 sine 22 whole divided by sine 22 sine 23. Right? So now, see, this is sine A plus B into cos A minus B. This is the formula for cos A minus B, that is cos 23 minus 22 degree. Minus, this is sine A cos B plus cos A sine B. This is the formula for sine A plus B. Whole divided by sine 22 into sine 23. This is equal to cos 1 degree minus sine 45 degree, right? Now let's multiply the numerator and the denominator with 2. So you are having over here 2 sine 22 degree, sine 23 degree. I hope you're clear till here, right? So now this can be written as 2 cos 1 degree. Sine 45 is given by 1 by root 2 whole divided by 2 sine A sine B. This is the formula for sine A minus B, that is 1 degree into sine minus cos, not sine, sine A cos A minus B, that is 23 minus 22, that is 1 degree, cos A plus B, which is 23 plus 22, that is equal to cos 45 degree. This is equal to 2 cos 1 degree minus 1 by root 2 whole divided by, this is 1 degree, okay? This is divided by cos 1 degree minus 1 by root 2 again. So you have the same thing in the numerator and the denominator. That means you have this 2 as your answer. So we have options B as the answer to our problem. Hope you are clear. Let's move to the next question, number 21. In a triangle ABC, A plus B plus C. Sine 2A plus sine 2B plus sine 2C is equal to what? This is, you have to find out. All right. First thing, you know, in any triangle, A plus B plus C, this is equal to pi. That means A plus B is equal to pi minus C. Now, the angles are sine 2A, sine 2B, sine 2C. Sine 2A, 2 sine. So this whole thing, sine 2A plus sine 2B plus sine 2C, this can be written as 2 sine 2A plus 2B upon 2 cos 2A minus 2B upon 2 plus sine 2C can be opened as 2 sine C cos C. Hope you are clear. So this is equal to 2 sine A plus B into cos A minus B plus 2 sine C cos C. A plus B can be written as pi minus C, and I will not touch this A minus B. So this is 2 sine C cos C, which makes it equal to 2 sine C brackets cos A minus B plus cos C, which gives 2 sine C cos A minus B plus cos pi minus A plus B, which is 2 sine C cos A minus B minus cos A minus B. They will cancel out, and over here you will have, this is the last step. I'll rewrite it. 2 sine C cos A minus B minus cos A plus B. So this is equal to 2 sine C multiplied by 2 sine A sine B. See, cos A minus B minus cos A plus B will give you 2 sine A sine B. So this on multiplication altogether is 4 sine A sine B and sine C. So here we have, let's check with the options. 4 sine A sine B sine C is option D. So this is the answer to our problem. Hope you are clear with this. Let's move to the next. Sorry, this is not D, this is A option. Right, here we have option A as our answer. Next is question number 22. So trigonometric problem again, let tan 30 and tan 15 be the roots of this quadratic equation. A is x squared plus ax plus b. Then 1 plus a minus b is equal to. Now, you know, tan 15 can be written as tan 45 minus 30, right? Which is equal to tan 45 minus tan 30 upon 1 plus, this is, sorry, tan 45 plus tan or 30. So 1 minus 1 by root 3 upon 1 plus 1 by root 3, which on solving will give you root 3 minus 1 upon root 3 plus 1. So now tan 30 and 15, they are given to be the roots of the quadratic equation. Tan 30 and 15, they are roots of x square plus ax plus b is equal to 0. Now, you know, the sum of the roots is given by sum of roots over here is given by minus a upon 1. Minus a, right? That means tan 30 plus tan 15. This is equal to minus a, right? And similarly, you know, the product of the, let's solve it also. So tan 30 plus tan 15. This is given by 1 by root 3, and tan 15 we just solved. It was equal to root 3 minus 1 upon root 3 plus 1. This is equal to minus a. Root 3 plus 1, root 3 plus 1 minus 3 minus root 3. They will cancel. And this is equal to minus 2 upon root 3 into root 3 plus 1 is equal to minus a. A minus and minus will get cancelled, right? Okay, minus and minus will get cancelled, and you will have this as, wait a minute. Here was plus, and this is supposed to be 4 then. This gives you a is equal to minus 4. Question number 22, let tan 30 and tan 15 be the roots of the quadratic equation x squared plus ax plus b is equal to 0. Then you have to find out the value of the expression 1 plus a minus b. So basically what you have to find out is a and b values in the question. You know the value of tan 30, it's 1 by root 3. Tan of 15, I don't know, but we can find out. How? Tan 15 can be written as tan 45 minus tan 30, which is of the form tan of a minus b. The formula for the same is tan a minus tan b divided by 1 plus tan a into tan b. So tan 45 into tan 30. Right? Now, tangent of 15 is equal to tan, and this is 1 and this is 1 by root 3 whole divided by 1 plus 1 into 1, 1 into 1 upon root 3. This on solving will give you a total, like rationalizing the denominator or simply LCM also. So you will have it as not rationalizing the denominator, simply the numerator and denominator. Multiplying with root 3, you will get this as root 3 minus 1 and root 3 plus 1 in the denominator. So now you are given that tan 30 and tan 15 are the roots of this quadratic equation. What is x squared plus ax plus b is equal to 0. Therefore, you know the value. Sum of the roots is given by minus the coefficient of x upon the coefficient of x squared. That is the coefficient, that is a. So sum of the roots, that is equal to tan of 30 is 1 by root 3 and tan 15, it is this. We just calculated, right? We have to fill in over here. So now let's take the LCM. Root 3 into root 3 plus 1 is equal to root 3 plus 1 plus 3 minus root 3 is equal to minus a. So you will have these two will cancel and you will have 4, or you can say minus 4 upon root 3 into root 3 plus 1 is equal to a. So you got the value of a. Now we need the value of y. For the sum of the roots, you know, this is the formula. And what about the product of the roots? Product of the roots is given by c upon a. That is the constant upon the coefficient of x squared. That means this is equal to b. That means tan of 45 into tan of 30 degree is equal to b. That means 1 into tan of 30 degree is given by root 3. Root 3 minus, let me confirm. Root 3 minus 1 upon root 3 plus 1. This is equal to b. Sorry, the two roots were not tan 45 and tan 30. It's tan, okay, sorry, this is a mistake. It is actually tan 30 and tan 15. So tan 30 multiplied by tan 15 is equal to b. Tan 30 is equal to 1 by root 3 and tan 15 we just solved. This is root 3 minus 1 upon root 3 plus 1 is equal to b. So root 3 minus 1 upon root 3 into this is equal to b. Plus 1 is equal to b. Now what you had to find out? You had to find out 1 plus a minus b. So 1 minus of 4 upon root 3 into root 3 plus 1 minus b. B was equal to minus root 3 minus 1 upon root 3 into root 3 plus 1, which will give you root 3 into root 3 plus 1 minus 4 minus root 3 plus 1 whole divided by root 3 into root 3 plus 1. So this is, let's open, you will have 3 plus root 3. What is this I have written? I can't get it myself. I think this is plus 1. Yes. So this is minus 3 minus root 3 whole divided by root 3 into root 3 plus 1. They will cancel, and you will have 0 as your answer. So that means we have over here option A as the answer to our problem. Hope you're clear. Let's move to the next question, number 23. Now again a trigonometry problem from with us. Sine tangent of x plus cos of x divided by 1 plus sine x is equal to what? Now this tangent x, this can simply be written as sine upon cos plus cos x 1 plus sine x. Let's take the LCM. So you will have cos x 1 plus sine x. This will make it sine x plus sine square x plus cos square x. This makes it sine x plus 1 upon cos x 1 plus sine x. They will cancel out. And you will have 1 upon cos, that means secant x as the answer to our problem. Option C. Clear? Next is question number 24. So in a triangle ABC, if R1 is greater than R2 is greater than R3, then which of the following is true? Now, what is R1, R2, and R3? See, R1 can be written as delta upon S minus A, R2 delta upon S minus B, and R3 delta upon S minus C. It's given that they are having this order. This is greater and this is greater than this, right? So that means if I'm reversing them, taking their reciprocals, first of all, the deltas will cancel and you will have S minus A is less than S minus B S minus B is less than S minus C. right? Which means, and you will it evaluate further, you will have minus a is less than minus b, less than minus b is less than minus c, which simply means a is greater than b is greater than c. That's it. So let's check with the options. We have a as the answer, right? Next is question number 25. So it says if k belongs to the real number is such that this equation has no real solution, then which of the following is correct? All right. So you are given 2 cos h square x is equal to 3 sin hx plus k. You know one thing, let's start with this thing. You know one thing for this such type of questions, that cos h, wait, cos cos h square x minus sin h square x is equal to 1, which simply can say cos h square x is equal to 1 plus sin h square x, right? This cos h square x can be written as 2 into 1 plus sin h square x. See, what I'm doing is actually I'm filling this cos value over here. Okay, so 2, 1 plus sine square h, sine h square x minus sine hx minus k is equal to 0. Now, this is becoming a quadratic equation, but let's simplify it further. You will have 2 sine h square x minus 3 sine hx plus 2 minus k is equal to 0. Now, this is a quadratic equation. It is said in the question that it has no real solution. If it has no real solution, that means the discriminant is less than 0. What is the discriminant? It's given by b square minus 4ac. This is less than 0. B square is the coefficient, b is the coefficient of x. Actually, this is the equation in sin hx. So what is b in this case? B is minus 3, a is 2, and c is 2 minus k. That means minus 3 whole square. This is sine square hx. So I'll write it like this. Sine hx square minus 4. A is 2 sine h square x and c is 2 minus k. This is less than 0, right? See, these are the coefficients of these sine hx. So a is, wait, so this becomes 9 sine h square x minus 8 sine h square x into 2 minus k is less than 0. 9 sine h square x minus 16 plus 8k sine h square x. Yeah, if this is less than 0. So this makes it sine h square x. Let's take that common. 9 minus 16 plus 18. Here I forgot to write sine h square x. So wait, my pen is lagging a bit. So this is sine h square x. You can write it as 9 minus 16 plus 8k is less than 0. That means 9 minus 16 plus 8k is less than 0, which simply will say you 8k minus 7, that will go on that side. So 8k is less than 7 or k is less than 7 by 8. This is the value of the k we were looking for. So I'm repeating the whole sum once again. In the question, we were given that this is the given equation and this has no real roots, right? For that, first of all, we use this identity and we use that value of cos h square x is equal to 1 plus sine h square x. we put this cos square x in the given equation over here, right? So after solving, this becomes a quadratic equation. In the problem, it is given to you that it has no real solution. If there is no real solution, that means the discriminant is less than 0, right? So discriminant is what? B square minus 4ac. So B was actually equal to minus 3 sine hx. You can write down, or even you can omit it. That's not a problem at all. If you don't want to use sine hx over here, that's absolutely okay, because we are considering that as a variable now. So a b square, that can be taken as 9, right? Minus 3 square will be 9. And 4ac will give you minus 16. Minus 4ac will give you minus 16 plus 8k. So this has got to be less than 0. Which on solving will give you that k's value is less than 7 by 8. And this is our answer. Now let's check. We have option C as the correct answer. Right? Clear? Next is question number 26. It says in a triangle ABC, if angle A is equal to 60 degree, then A plus B plus C multiplied by B plus C minus A is. So very first thing, you know A plus B plus C is 180. So if you are given A is 60, that simply means B plus C is 120. B plus C is equal to 120 degree, right? One more thing, by the sine rule. By sine rule, what do you have? You have A is equal to K sine A, B is equal to K sine B, and C is, this is small c actually, okay? Pay attention to this. So this is equal to K sine C, right? Now let's fill in. What do we want to find out? We have to find out this. A plus B plus C, B plus C minus A. This can be written as B plus C square minus A square. So B plus C square, this can be written as K square sine B plus sine C whole square, K square sine square A. So this can be written as K square 2 sine B plus C upon 2 sine B minus C upon 2 whole square. Sorry, this is not sine, this is cos. Cos B minus C upon 2 whole square minus K square into sine A. You know, sine A was 60 degree. That is equal to root 3 by 2. When I'm taking square of it, it will be 3 by 4. Hope you're clear with this. So now next thing, I'll take K square common. B plus C upon 2, B plus C is equal to 120. So 120 upon 2 gives you 2 sine 60 degree, and cos B minus C upon 2 whole square is minus 3K square upon 4. So this gives me sine 60 degree is root 3 by 2, right? When I'm taking the square of it. Okay, just, yeah. So when I'm taking square of it, this will be 2 root 3 multiplied by cos B minus C upon 2 whole square minus 3K square upon 4. They will cancel out and you will have 3K square cos square B minus C upon 2 minus 1 upon 4. Right now, let's solve it further. And what I'll be doing next step, I'll say 3 by 2 K square 2 cos square B minus C upon 2 minus 1 by 2. So this will become 3 by 2, like whole this thing is clear to you. Now what I'll be doing, I'll be adding and subtracting 1. 2 cos square B minus C upon 2 minus 1 plus, minus 1 plus 1. Minus 1 plus 1 minus 1 by 2. This is equal to 3 by 2 K square. So 2 cos square B minus C minus 1. This gives me cos B minus C plus 1 by 2. Hope this thing is clear till here. So now further, you can write it as 3 by 2 K square cos B minus C. 1 by 2, this can be written as cos A because cos 60 degree is equal to 1 by 2. So this will be 3 by 2 K square cos B minus C plus here was so this can be written as this will become minus C now. Minus, I'll rewrite this line. This will be 3 by 2 K square cos B minus C minus cos B plus C. This is equal to 3 by 2 K square multiplied by 2 sin B sin C. Or this is equal to 3K sin B K sin C, which is actually 3BC, right? So let's check what we have in the options. 3BC is option A. So this is the correct answer for our problem. Hope you are clear. Let's explain this question once again. We were given that angle A is equal to 60 degree, which simply meant B plus C is equal to 180 degree. Now using the sine rule, we had these three things. I'll fill in all these values in the given equation, what we had to find out. And after that, it is just the calculations. You have to solve the apply the trigonometric identities and solve them. Okay. Let's move to the next question, number 27. In a triangle ABC, if R1 is 12, R2 is 18, R3 is 36, then B is equal to. All right, you know one thing, 1 upon R is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. So 1 upon R1, R can be written as 1 upon 12, 1 upon 18, 1 upon 36. So now let's take the LCM. It will be 36. So 3 plus 2 plus 1, which will be equal to 1 by 6, which gives you R is equal to 6. But we have to find out B. For that, you know one thing, delta square, this is written as R into R1, R2, R3. So delta square is equal to 6 into 12 into 18 into 36. That means when I have to find out the delta, I have to find the root of it. 6 into 12 into 18 into 36. When you will find out the root of it, you will get 216 as the root of it. So delta is equal to 216, right? We also know one thing, R is equal to delta upon S. That means S is equal to delta upon R. Delta is 216 and R was 6, which gives you S is equal to 36, right? So next, R2 is given by delta upon S minus B. Delta was 216, S was equal to 36, and B we have to find out. R2 we already know, R2 is equal to 18. So 18 is equal to 216 upon 36 minus B, which gives you 36 minus B is equal to 12, or B is equal to 24. Thus, we got the value of B. This is equal to 24. Let's check with the options. We have option C as our answer. Hope you're clear with this. Let's move to the next question. Question number 28. If R1, R2, and R3 of a triangle ABC are in harmonic progression, then ABC will be in what? Arithmetic, geometric, harmonic, or arithmetic geometric progression. But you are given that R1, R2, and R3, they are in... Wait, there is some problem. My pen is lagging. So they are in harmonic progression. That means 2 upon R2 is equal to 1 upon R1 plus 1 upon R3. 1 upon R1 plus 1 upon R3, which will, like you can write down this 2 upon S minus B upon delta is equal to S minus A upon delta plus S minus C upon delta. This will give you 2S minus 2B is equal to S minus A plus S minus C, or 2B is equal to minus A minus C, which will give you 2B is equal to A plus C. That means they are in arithmetic progression, AP. So option A is the correct answer to the problem. Hope you are clear. Let's move to the next question. Question number 29. If A and B are the two non-collinear vectors and vector A plus B bisects the angle between them, then which of the following is true? First thing, let's draw them. See, you are given, let's draw the figure first. If I'm saying this is, wait, let me draw first. So here I am, here is O, A, let it be C, let it be D, and I'm naming this one, this point as B, right? So here OA is A vector and wait, OA is A over here and this OD is B, right? And similarly, this is also B, right? Let's write down OD is equal to AC is equal to P vector, modulus of P vector. So I hope this is clear to you. So now let's consider the triangle ABC. In triangle ABC, AB is equal to mod of P cos of 2 theta. Now what is 2 theta? If I'm considering this angle as theta, then this is also theta, then of course this angle is equal to 2 theta, right? This is this direction, yes. So AB is equal to B cos 2 theta. Similarly, BC is equal to B sine 2 theta, right? Next, in triangle OBC, let's see the triangle OBC, this one, OBC. Tangent of theta, since this is a 90-degree angle, tangent of theta can be written as B sine 2 theta upon A plus B cos 2 theta, which is equal to 2B tan theta upon A1 plus tan square theta plus B1 minus tan square theta, which will give you question number 29. If A and B are two non-collinear vectors, then the vector A plus B bisects angle between them, then, okay, you have to find out which of the following is correct. For that, let's first of all frame the figure. So here it is. Let's frame it. You will have something like this. So let it be O, A. And let us follow perpendicular from here. And name this point as B, C, and D. You are given A and B are two non-collinear vectors such that vector A plus B bisects the angle A and angle between A and B. So if I'm assuming this one as to be A and this vector to be B vector, so this has got to be your A plus B, OC. This is A vector plus B vector. Right? Now, this is bisecting. So if this is theta, then this is also theta. And this is got to be 2 theta because they are the corresponding angles. Right? Hope you're clear till here. Next thing, we are taking OA is as A and OD vector, which is equal to AC vector, is equal to modulus of B vector. Okay, let's write down a few things more over here. If I'm taking in this triangle, what is AB and BC equal to? Let's find it out. In the triangle APC, AB will be given by B cos 2 theta, right? Let's write it down. This will be given by B cos 2 theta, and in the same triangle BC will be given by modulus of b sine 2 theta. So this is given by modulus of b sine 2 theta. Right, I think we are done with all the sides. Now let's just go with the solution. What you were asked, like we have to find out the correct option. In triangle OBC, if you look at the triangle, then tan theta is given by P sine 2 theta whole upon A plus B cos 2 theta. So now let's open it up. Sine 2 theta can be written as 2 sine theta cos theta whole divided by A plus B cos 2 theta can be written as cos square theta minus sine square theta. Now dividing the numerator and the denominator by cos square theta, it will give you 2b tan of theta upon A secant square theta plus B 1 minus tan square theta. This was equal to tangent of theta only. So tan of theta is equal to 2b sine theta upon secant square can be written as 1 plus tan square theta plus b 1 minus tan square theta. Sorry, here was tan theta, not the sine theta. Right. So this is tan of theta. Actually, they will cancel. We'll cancel it now. So 2b tangent of theta, they will cancel out. And here you will have, this will be a plus b. And here will you have, this is a plus b. And I'll have plus tan square theta a minus b. Right. So you will have, let's do the cross multiplication, a plus b plus tan square theta a minus b is equal to 2b, which will give you a minus b plus a minus b into tan square theta is equal to 0, a minus b into 1 plus tan square theta is equal to 0. This will give you a minus b is equal to 0, which will mean nothing but a mod is equal to b mod. So we have our answer. Here it is, option A. Hope you are clear. Next is question number 30. It says OABCD is a pentagon in which the sides OA and CB are parallel to these two sides. OA and CB are parallel and the sides OD and AB are parallel. Also, it is given that OA is upon CB is equal to 2, OD upon AB is equal to 1 by 3. If OA is equal to A vector, OD is equal to D vector, then AD plus OC plus DC is equal to what? Okay, again, let's make the figure first. So here I have, let this be OA, which represents your A vector. Then I have this D and like over here, like this and like this, right? So this is OA, B, C, D. This is a pentagon. Now you are given in the pentagon that OA and CB, they are parallel sides. So they are parallel sides. OD and AB are the parallel sides. These ones. Also it is given that OA upon CB is equal to 2. OA upon CB is equal to 2, which means OA is equal to half of CB, or you can say CB is equal to half of OA is equal to twice of CB, or CB is equal to twice of, sorry, I'll rewrite. CB is equal to half of OA. That means this is equal to A by 2. One thing. Next, you are given that OD upon AB is equal to 1 by 3. OD upon AB is equal to 1 by 3. OD, if I'm taking as, let it be D. then what will be AB? If I'm taking this as D, so AB will be equal to 3D. Correct. Now, you have to find out AD plus OC plus DC factor. Let's go for this. So, here, AD plus OC plus DC factor. AD can be written as AO plus OD. OC can be written as OA plus AB plus BC. DC can be written as DO plus OA plus AB plus BC. Now let's fill in the values. AO is minus A. This is D plus A plus 3D minus A by 2 plus minus D plus A plus 3D minus A by 2. So you will have, this will cancel out with this. And over here, next, this is minus A by 2, and plus A. They will cancel out. And this D and this D will get cancelled. You have 6D as your answer. So we have option D as the correct answer for our question. Right? Clear? Next is question number 31. If the points P and Q and R and S, these are the 4 points. This is first point P. This is point Q, R and S. They are consecutive vertices of the parallelogram P, Q, R, S. Let's make that parallelogram. I have this parallelogram. So this is P, 1, 2. This is Q, 4, 6. R, 5, 7, and S, A, B. These are the vertices of the parallelogram P, Q, R, S. So this is P, Q, R, and S. Accordingly, these are the vertices. Now first just let me make the diagonals. So let the point of intersection of the diagonals be equal to A, BA. So I'm taking the A as the point of intersection of the diagonals PR and QS. You know, diagonals of the parallelogram bisect each other. So that means A is the point of intersection of the diagonals PR and QS. A is also the midpoint of both these lines. A, point of intersection of PR and QS. A is also midpoint of PR and QS. Now let's find out A. A will be given by 1 plus 5 upon 2, 2 plus 7 upon 2, which is equal to 3, 9 by 2. Now, this is why I have applied the midpoint formula. Midpoint formula over here. Also, another thing, let's verify if I'm taking QS. A is equal to, if I'm taking QS, then this is equal to 4 plus A upon 2, 6 plus B upon 2, which is equal to 3, 9 upon 2. That means 4 plus A upon 2 is equal to 3. Also 6 plus B upon 2 is equal to 9 by 2. This gives you A is equal to 2 and this gives you B is equal to 3. You had to find out AB. That becomes 2, 3 and this is the answer. So we have 2, 3 option C as our answer. Right? Next is question number 32. If A is a vector, B is this vector, C is the projection vector of A on B, then C and C, a modulus of C respectively are what are these values? Okay, so first thing you are given A vector as 4I plus 6J and B vector as 3J plus 4K. C is a projection vector of A on B because C is projection vector of A on B. Therefore, C is equal to A dot B upon B, which is equal to 4I cap plus 6J cap, 3I cap plus 4K cap, whole divided by 3 square plus 4 square, which gives you C is equal to, C factor is equal to 18 upon 5J. Let's take the modulus. So modulus will be equal to 18 upon 5. Only this is the C modulus, right? We have found one thing. We had to find out the modulus of C. We got the 18 by 5 value. So most probably we got our answer, but still let's check. We have to find out the C factor as well. So modulus of B factor is equal to 5, right? You have, if I'm doing C factor upon B factor modulus, this is equal to 18 upon 25, correct? This, that means, see, what do you have to find out? The C factor. C, you have to find out this C vectors. Since C and B, because C and B are collinear vectors, therefore, C can be written as 18 upon 25 of B. So this is what we were finding out. Actually, C was given in the terms of B. So we have option C as our answer. The C value is given by 25 upon 18B. Question number 32. If A vector is this, B is this, and C is the projection of A vector on B vector, then C and the mod of C respectively are. Easy question, right? Not a problem. So you are given that the A vector is equal to 4I plus 6J and B vector is equal to 3J plus 4K. Right. Now you are given that C is the projection of A on B. C is projection of A along B, right? Then C can be given by A dot B upon the mod of B, right? So the C can be given like this. That means it is, this will be equal to 4 into 0 plus 6 into 3 plus 0 into 4. So this whole is divided by root of B 3, that is 9. 3 square is 9 and 4 square is 16. So this will be given by 18 upon 5. This is the projection of A along B. That is, this is equal to the mod of C. Correct? One thing. Now you have to find out C vector as well. Since the vector is determined, C vector will be determined by the projection 18 upon 5 B cap, which is equal to 18 upon 5. B vector was 3. B vector was 3J plus 4K. 3J plus 4K whole divided by 5. That means this is equal to 18. I hope you know this. Like, this is the root of, again, let me explain. This is root of 3 square, that is 9 plus 16, that is 4 square, which will give you 25, right? Okay, this is, yeah. So this will be equal to 5. So 18 upon 25 B vector. This is the C vector, right? Now let's check with the options. We have option A as our correct answer, right? Clear? Next is question number 33. Distance between a point P whose position vector is given by this and the line this is. All right. So you are given position of the point P, whose position vector is this, and the line R, this is. P vector is given by 5i plus j plus 3. Okay, that means the P point is given by 5, 1, 3. Now you are given R as 3i cap 7j k plus this is T times jk P j plus k. So the line passes through the point Q, that is 3, 7, and 1. Therefore, PQ will be given by this is 3i minus 5i, 7i minus 7j minus j, and k minus 3k. Right, this will be minus 2i plus 6j minus 2k. This is the PQ. Now the direction vector of this line is direction vector of line is j plus k. You have to find out the distance, and the distance will be given by PQ multiplied by j plus k upon the mod of j plus k. What is the mod of j plus k? This is equal to root of 1 square plus 1 square, which is equal to root 2. So this becomes equal to 1 by root 2. PQ is given by this vector, right? And this j plus k is this. This can be written as I, j, k minus 2, 6 minus 2, 0, 1, 1. Now let's find out the mod of it. 1 by root 2 into iota, sorry, not iota, I cap, 6 plus 2 minus j minus 2 plus k minus 2, right? The mod of it. So this will be given by 1 by root 2 of 8i plus 2j minus 2k. This is equal to, let's multiply the numerator and the denominator by root 2. So you will have it as root 2 multiplied 4i plus j minus k modulus. So this is given by root 2 of root of 4 square plus 1 square plus 1 square, which is root 2 into root 18. So root of 36, that is equal to 6. So you got the value which we were looking, that is the distance. This is what we find out. We were finding out the distance D. Distance came out to be 6. So this is the answer to our question, option B. Right? Clear with this? Next is question number 34. The mean deviation from the median for the following data is. This is the given data. Let's make a table of it. So first xi, that is 10, 11, 12, 13. This is fi 6, 12, 18, and 12. CF is given by 6, 18, 36, and here will be 48. Next, xi minus m. Now, what is this m? Let's discuss that first. See, over here, n, that is the sum of the frequencies. This n is given by 48. Look over here, this n is given by 48. Therefore, the half of this is equal to 24. That means your median is 24th observation, right? That means your median is equal to 12. This is your median. 24th observation, this will be equal to your 12. This is the median. So xi minus m, this will be like 10 minus 12, it will be mod of it. So 2. Next, xi minus, that is 11 minus 12, mod of that is equal to 1. And next 12 minus 12 will give you 0. 13 minus 12 will give you 1. Next is fi into xi minus m. Let's multiply it with frequency. So 6 2s are 12, 12 1s are 12, 18 zeros are zeros, and 12 1s are 12, which gives you a total of 36. So you're asked the median, the mean deviation from the median. So this is the mean deviation from the median formula. Mean deviation is given by summation fi xi minus m whole divided by n. So that means 36 divided by 48, that is equal to 0.75 or 3 by 4. Right. Let's check with the options. We have option A as the answer to our problem. Right. Next is question number 35. 3 unbiased coins are tossed and the probability of getting the most 2 heads is what? 3 unbiased coins are tossed. So you have the sample space as head, 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 tail, head, tail, head, or head, tail, tail. Then tail, head, head, tail, head, tail, 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 head, or tail, tail, tail. This is the sample space. Now, n of s, number of these is given by 8. Let E be the event of getting at most 2 heads. Let E be the event of getting at most 2 heads. That means the probability E dash is equal to H, H, H. Now, what does this thing mean? That means the question was asked the probability of getting at most 2 heads. That means we can't have 3 heads over here. This is not allowed. Everything else apart from this is okay. So E dash will be given by 3 heads. This is the event when you will be having 3 heads. So probability of the event to happen is given by 1 minus probability of the event not to happen. So 1 minus n of E dash upon n of S, that is equal to 1 minus 1 by 8, or this is equal to 7 by 8. This is the answer to our problem, option D. Right? Next is question number 36. A box has 6 black, 4 red, 2 white, 3 blue shirts. When 2 shirts are picked randomly, then the probability of either both are white or both are blue is. So first of all, in the box, you have 6 black, 4 red, 2 white, and 3 blue shirts. Then 2 shirts can be picked up in, how many shirts are total? 15 shirts. Now, 2 shirts can be picked in 15C 2 ways. So, 2 white shirts can be picked in 2C2 ways. Right? 2 blue shirts can be picked in 3C2 ways. Now the probability of getting 2 white shirts will be given by 2C2 upon 15C2, and the probability of getting 2 blue shirts is given by 3C2 upon 15C2. Right? In the question, what we are asked, the probability that either both are white or both are blue. So the required probability is given by 2C2 upon 15C2 plus 3C2 upon 15C2. This gives you 2C2, 3C2 upon 15C2. So 2C2 is, let's see, 2C2 is given by 2 factorial upon 2 factorial into 0 factorial, which is equal to 1. And 3C2 is given by 3 factorial upon 2 factorial into 1 factorial. So this is equal to 3. 1 plus 3 upon 15 factorial upon 2 factorial into 13 factorial, which will be 4 upon, okay, let's solve it. 15 upon 2 into 13 is given by 15 into 14 upon 2, or 15 sevens are, which is equal to 105. So this is given by 4 upon 105. So we got our answer. Here we have option A as the answer to our problem. Right? Clear? Next is question number 37. 2 dice are thrown simultaneously. The probability of getting a multiple of 2 on one dice and a multiple of 3 on another dice is. So you are throwing 2 dice simultaneously. What will be the sample space? The number of possible outputs are 36. 6 on one dice multiplied by 6 on another dice. The total number of the sample number of outputs that are possible in the sample space are given by 36. Now, what the question is, probability of getting a multiple of 2 on one dice and a multiple of 3 on another dice. So let E be the event. Let E be the event of getting multiple of 2 on one dice and multiple of 3 on another dice. Okay, so E1 can be given as 2, 3, 3, 2, 4, 3, 3, 4, 6, 3, 3, 6, 2, 6, 6, 2, 6, 2, 4, 6, 6, 4, and then finally 6, 6. So these are the possible events that are possible, right? This is E. Now, the number of possible outcomes in this event is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This is equal to 11. That means the probability of the event is given by N of E divided by N of S, which is equal to 11 upon 36. So this is the answer to our problem. We have option B as the answer. Right? Yeah. Next question number 38. Two persons, A and B, take part in a shooting competition. A can hit the target with the probability of 0.6 and B can hit the target with the probability of 0.8. A has the first shoot past which they strike alternatively. Then the probability that A wins the competition is. Okay, so you are given that the probability A will win is 0.6 and the probability B will win is 0.8. That means the probability A will not win is 1 minus 0.6, that is equal to 0.4, and the probability that B will not win is given by 0.2. Therefore, probability that A wins, probability that A wins is probability PA plus PA dash plus P, oh sorry, not plus, it's multiply. PA plus PA dash into PP dash into PA plus PA dash. This is PB dash into PA dash into P. This is confusing a bit. Wait. P B dash P A, so on. That means the probability that A wins is given by 0.6 plus 0.4, 0.2, 0.6 plus 0.4 square, 0.2 square, 0.6, and so on. Probability A wins is 0.6 upon 1 minus 0.4 into 0.2. Why? Because the above series, this is a GP series. Above is a GP series, that is geometric progression series. Therefore, sum will be given by 0.6 will be taken outside. This is given by A minus 1 upon R, where R is the common ratio, multiple. Here, A is equal to 0.6 and R is equal to 0.4 into 0.2. This is an infinite GP series. This is the formula for the infinite GP series. Let's solve it. 0.6 into 1 minus 0.08. This will give you 60 upon 92. That means probability that A wins is given by 15 upon 23. This is the answer to our question. We have option B as the answer. Hope you're clear with this. Let's move to the next question, number 30. In a binomial distribution, if P is equal to Q and N is greater than equal to 4, then this is given by. You are given P and Q, they are equal. So also you know one thing, that P plus Q is equal to 1. If they are equal, that means P is equal to Q is equal to 1 by 2. Right? Now, 2 raised to power N P x minus 5 is equal to. So 2 raised to power, this is equal to 2 raised to power N into N C 5 P N minus 5 multiply Q raised to power 5. This is given as 2 raised to power N into N C 5 1 by 2 N minus 5 into 1 by 2 5. 2 raised to power N into NC5 into 1 by 2 raised to power N, because minus 5 and plus 5, they will cancel out. And you will have, this will be 2 raised to power, like these two things will cancel out. And you will have NC5 as your answer. Let's check. We have option D as the correct answer to our problem. Hope you're clear. Next is question number 40. A random variable x follows the binomial distribution and x belonging to bn, 0.3. If the mean of x is 3 times as large as standard deviation of x, then n is equal to. Here you are given that the probability of the event to happen is 0.3. That means the probability of event not to happen will be equal to 0.7. Mean, that is mu, is equal to 3 times standard deviation. Okay. Mu is also equal to NP, that is equal to 0.3. N. Also, standard deviation can be given by NPQ whole under the root. So this is given by N into 0.3 into 0.7, which will be equal to 0.21 into N. So these two things, they will be equal from equation. Let this one be equation 1. And over here, let this one be equation 2. Now equating, you will have mean, that is mu is equal to 0. Okay, I'll just fill in the value over here. Mu is equal to 3 into n, right? So this is the value. This is equal to 3 into 0.21 into root n. Mu is also equal to 0.3 n. This is equal to 0.21 n. And you will have it further. Let's do the, we'll get it as 0.1, or you can write it as 3n upon 10 is equal to 3 into root of 21n upon 100. This will cancel out and you will have n by 10 is equal to root of 21n upon 10. They will also cancel, and squaring the both sides, you will have n square minus 21n is equal to 0, or n, either n is equal to 0 or n is equal to 21. N can't be equal to 0. This is not possible. So n will be equal to 21. This is the answer, option B. Question number 77. Integral 9 from 9 to x fy upon y square dy is equal to 2 root x minus 6. Here fx is given by what? So we'll be solving this problem using Leibniz rule, differentiating both sides using Leibniz rule. What you will get? So this will be fx upon x square is equal to 2 upon root 2 root x. Right? So 2 upon this root x will be 2 upon 2, 1 upon 2 root x. Right? So fx over here will be equal to x square, 2 will cancel, into 1 by root x, which will be x root x. So using this rule, this was a pretty easy question, hardly half a minute problem this was, and we have option B as the answer. Right? Next is question number 78. If the solution of dy by dx is equal to this much and y of 0 is 1 and 1 by y square is this, then you have to find out fx. So you are given dy by dx is equal to y cube cos of root x whole divided by root x into e raised to power 1 by y squared. I'll take 1 e raised to power 1 by y square upon y cube this side into dy, and cos x upon root x into dx on another side. Right? Let's take the integral on both the sides. Now, this can't be solved. I'll be putting something. 1 by y square is equal to t, which gives me minus 2y y cube into dy is equal to dt. Another thing, I'll be putting root of x is equal to u. So if root of x is equal to u, then du will be equal to 1 by 2 root x into dx. We got all the things. Now we'll be just filling it in our problem. Okay. So this whole integration will become integral et dt upon minus 2. This is equal to 2 cos u into du. So this integral will evaluate to minus 1 by 2 e raised to power t, and this is equal to 2 sine u plus some constant, let it be k. Now I'll be putting the value of t. This is minus 1 by 2 e raised to power 1 by y square is equal to 2 sine root of x plus k. You are given one more thing, that y of 0 is equal to 1. That the function is at x is equal to 0 is equal to 1, which means when x is 0, y will be 1, right? So this will be, this thing will be minus 1 by 2 e raised to power 1 upon y as 1 is equal to 2 sine root of 0 plus k. Right? So this is equal to, when I'm putting this as 1, This will be e raised to power 1 and this will be minus e by 2, right? I'm putting this as 1. Sorry, y was 1 over here. So minus e by 2 is equal to 2 sine 0, which is 0. So k becomes minus e by 2. This is what? Now the whole expression, this one, we had to find out the value of k. This whole expression 1 will become 1 will be minus 1 by 2 e raised to power 1 by y square is equal to 2 sine root x plus minus of e by 2. Now, taking log on both the sides with the base e. Taking log on both sides with base e. This will be log of minus 1 by 2 e raised to power 1 by y square is equal to log of this whole thing. 2 sine root x minus e by 2. So this is equal to log of minus 1 by 2 plus log of e raised to power 1 by y square is equal to, I'll not touch it, I'll keep it as such. So log minus 1 by 2 is actually log 1 minus of log minus 2. Wait, how will I write? Log of minus 2 plus 1 by y square is equal to log 2 sine root x minus e by 2. Log 1 is 0 and minus of minus log 2. This will be, I can write it like 1 by y square is equal to log of 2 sine x minus e by 2 multiplied by minus 2, because I'll be taking this one on this side. So it will be plus, so it will be multiplied. This will be, when I'll take log of minus 2 on the right hand side, it will be plus log minus 2. And if it is log plus minus 2, it will be multiplied inside the brackets, right? So 1 by y square will turn out to be log of e minus 4 sine root of x, right? So that means fx is equal to e minus 4 sine root of x, right? Over here, you were given that log e fx is equal to 1 by y square. So this can be written as log e fx, which gives you fx is equal to this term, right? Let's check with the options what we have. Option D is the answer. Hope you're clear with this. Let's move to the next question, number 79. Now, suppose that you are given two functions, f and g. They are the homogeneous functions of the same order, and you have x is equal to vy. It reduces the equation this to this form. Then f of v is equal to what? So now you know one thing you're given, dy by dx is equal to f xy upon g xy. One more thing, x is equal to vy. So if this is x is equal to vy, let's differentiate both the sides with respect to y. You have dx upon dy is equal to v plus y into dv upon dy, which gives you y into dv upon dy. Okay, yeah. Y into dv upon dy is equal to dx upon dy minus v, which gives you dv upon dy is equal to 1 by y dx upon dy minus v. So I will put this one, let's name this one as 1. From equation 1, we have this dv by dx sorry, dv by dy, what was this? dy by dx is equal to. So from equation 1, we have dx by dy is equal to gxy upon fxy. So this is equal to gvy comma y upon f of vy and y, right? So this becomes equal to gv1 and f of v1. Now let's put this one in this equation. So you will get dv upon dy is equal to 1 by y g v1 upon f v1 minus v. This is, see in the question, this is something of the form fv is equal to gv1 fv1 minus v, right? If you compare both of these equations, then fv will become equal to this, right? So this is our answer to the problem. Let's check. We have D as the answer. Hope you're clear with this. Then let's move to the last question, mathematical question of this paper. Here we go. We have to find out the general solution of x dy minus y dx is equal to y into dy. Let's write it down first. You were given x dy minus y dx is equal to y into dy. This can be written as minus of dx minus x dy is equal to y dy. So this is minus x dy upon y square. I'll divide both the sides by y into dy upon y square. So this will become equal to d of x upon y. This is equal to dy by y. Let's take the integral on both the sides, right? So here was minus, yes. So this will be minus x upon y is equal to natural log of y plus c, which makes y is equal to a into x raised to power y is equal to, just a minute. Y is equal to a into e raised to power minus x upon y. So we have option A as the answer. Hope you're clear with this. So students, with this, we have completed all the 80 questions of this paper. Hope you were clear with this. If you have any doubts, you can rewind the video and watch them again. And please don't forget to download our app. You have the link in the description box, and also visit our website, www.examsnet.com. Right? A very best of luck. Keep shining, keep rising high, keep studying and scoring high. Bye. Best of luck.